Okay, welcome back to the Python programming series in which we are learning Python from basics to the advanced level. This is the seventh video of this series where we are going to learn about functions in Python. This is the part 2. We have completed the part 1 in the sixth video. In this video, we are going to understand the advanced Python concept, that is default and keyword argument. Then we will understand Lambda function. We will understand about scope. We will also see what recursion is, and we will also understand math modules as well. Okay. So in the previous lecture, we have done the function definition. We learned how we can create reusable code block with def keyword. Then we learned about function call, that how we can call a function using its name and parenthesis. Then we learned about parameters. Those are the variables defined in the function header, and arguments are the values that is passed to the parameters during a function call. Then we learned about return statement, how we could send outputs back from a function. And then we learned about the roker variable, that are the variables which are defined inside a function and do not exist outside the function. So this was what we have covered in part 1 of our functions. So in this video, what we have to cover is we will be learning default arguments, fallback values when arguments are omitted. Okay, then we will learn keyword argument, passing values using explicit parameter name. Then we will be learning lambda function. Those are the single line, inline anonymous functions. And then we have global and local scope. We have learned about local scope a little bit in part 1. So we will be learning about global and local scope in details in this video. Then we will learn recursion, how function can call themselves in complex problems. And then we will learn about math module in Python that helps us in solving math and trigonometry easily. So this is today's agenda. And yeah, I am Shriya Keshri, and I will be helping you in learning and understanding all of the concept in these videos. Okay, so we will first start from the default argument. Yes, we are going to start from the default argument. A default argument is a parameter that comes pre-assigned with a value in the function definition. If no argument is provided during the call, Python automatically falls back to this default value. So what happens here? It says that whenever we are creating a function, whenever we are defining a function, we can pre-assign a value to the parameter. That is the default argument. We do not consider the fact that an argument is going to be assigned during a call. So we give it a default argument that can be used if there is no argument provided during the call. So this is the default argument that we automatically provide to a parameter. So what does the definition say? A default argument is a parameter that comes pre-assigned with a value in a function definition. So let us understand with an example here. We have learned that we can define a function using def keyword, and we have this function name, and it takes this parameter here, that is name, and then it prints out this name word. Okay, so now we are automatically assuming that whenever this name function will be called, then some value will be given here, some argument will be passed here for this parameter. Yes, but in this default argument, what we need to understand is that we can automatically give a value to this parameter, say let me So when I run this code with a parameter inside it, then it will take this value. But if I will run it without any argument inside it, then it will take this default value and it will print this Mayank. In this case, I am passing Shriya as an argument. So while printing the name, it is taking this argument that I have passed. But since in the second case, I am not passing any argument inside, it will take the default pre-assigned value from here and it will print Mayank. So this is how the default arguments work. So this is the first thing that we need to understand. This is the default argument. Okay. Yeah. There is an example here. We say def greet name equal guest, print hello name. So if we are going to call this greet function and we say that we call it like greet, and inside the parenthesis I write Shriya. So while we will learn, we run this code, then it will print hello Shriya. Why? Because Shriya is a argument here. But if I do not give any argument inside it, I will just the program will just print this guest from here as well. If I am not giving any argument while I am calling this greet function, then it will take the default argument that has been pre-assigned to name, that is guest, and it will print hello guest. So this is how default argument works. Let us see an example as well. This is the same example that we just discussed now. So here, def greet name is guest and print hello name. This is the function that we are defining. We are assigning a default value that is guest, and while we are calling it, we are first calling it without any argument, and second we are calling it with an argument Rahul. So when I will run this code, the first one without an argument will take this guest as its argument by the default argument example, and it will print hello guest. But in the second condition, I have specified the argument, so it will print hello Rahul. So what we understand here is when greet is called without values, name default to guest, passing Rahul overrides the default value. So this is what default argument is. Next, we have keyword arguments. What does this keyword mean? We have learned that while we write arguments for any parameter, we use positional order, right? If I write in parameter a comma b, then in the argument, a will be taking the first value and b will be taking the second one. Argument. So instead of relying strictly on positional order, we use keyword argument that allows us to pass values explicitly using parameter name. So in general case, what we have learned so far is that whenever we write a parameter such as a comma b, so when we call the function and we provide an argument such as 10 comma 3, then a will automatically take the first position's value, that is 10, and b will take the next position, that is 3. So this is how positional ordering works. But what if I do not want this positional order? We want to explicitly pass values. Then we can use this keyword argument. We can use it by writing the parameter name itself. We write the parameter name and then we assign the value like this inside the function call. This is how keyword argument works. So if I take this example which we were considering for the last topic, then I would say, yeah, this is the function, and now I am going to explicitly define the values that is going to be stored here. So I'm going to write like this. Now if I have another argument here, then I can write it like this. Now the order doesn't matter. I am writing age before name, but this won't be causing us any harm. Why? Because we are not using the positional order anymore. Earlier, we would write it like this. Then name will take the first value, that is Shriya. Age will take the second value, that is 19. But now order doesn't matter. Age can come first, name can come later, because now we are using keyword argument. So this is what we are doing here. Okay. So this is it. This is the keyword argument. Okay. So now there is a difference between positional and keyword argument. Now we have to discuss the differences between positional and keyword arguments. So positional arguments say that we need to match the order. So the order matters strictly. In keyword arguments, order does not matter. For positional argument, values mapped by the position index, but in keyword argument, values are mapped by parameter name. We explicitly write the name and then we assign the value to it in the keyword arguments. Then we have simple and concise for small function. Yes, positional arguments are simple and concise for small function, but whenever we have to write a big function where we need many arguments, then keyword arguments are better for self-documenting and it is more readable. Now, positional arguments can be error prone with many parameters, but in the case of keyword arguments, it can be very useful for function with numerous parameters. So this was the comparison between positional and keyword argument. Okay, now in this case, we are going to combine both of this argument, positional and keyword. So how we are going to do it? We write a student named function and we provide it with three parameters, that is name, age and city. So when we call this function here, we are writing Rahul for the first name. So since there is no keyword assigned with no keyword to which this value is assigned, so name will be given the value Rahul automatically. Then we have this city called is equal to Delhi. This is the keyword argument. So this Delhi will be stored with this city. Then here the order won't be affecting anything. Then we have age is equal to 20. So this 20 is going to store in this age. So while we will print the name, age and city, it will print Rahul, 20 and Delhi. Now the golden rule that we have to understand here is this: positional argument must always come before keyword argument. So such as in the example, we are writing Rahul before city and age. So this is what happens. We have to first write all the positional arguments and then after we can write keyword argument. Once you use a keyword argument in a function call, all subsequent arguments in that call must also be the keyword argument. We can't mix them together. We have to finish the positional arguments before we write the keyword argument. Okay. Now we have to understand some common syntax error. The first one here is invalid call. So so it says positional argument follows keyword argument. Yeah, we have learned about it already, that the positional argument follows keyword argument. Now, anyways, so if we are going to mix the order of positional argument and keyword argument, that will result in a syntax error. Why? Because positional argument always follows the keyword argument. Okay. So Python cannot determine which parameter the value 20 belongs to after keyword matching begins. Yes. So this is what happens. This is why we have to avoid passing keyword argument before positional argument, as when we start assigning a keyword. Okay. Yeah. Getting back to it. So here, when we are writing student name Rahul, comma 20. So when if we write the keyword argument before positional argument, then Python cannot determine which parameter the value 20 belongs to, because then it can't find the keyword matching with 20. So this is why we have to write all the positional argument before keyword argument. Okay. Next, we have to understand about the Lambda function. So Lambda function is a small unnamed function defined in a single concise line of code. It can accept any number of arguments but can only contain a single expression. What does it mean? Lambda functions are one single line code and it can accept any number of arguments but it can only contain a single expression. We write only one expression here. We can't write very many number of code as we were writing earlier. So Lambda function are only single line function. We can write as many argument as we want, but the expression, the function that is going to do will be a single line only. Okay. Now let's see this example. We are writing a lambda function inside this variable square. We say that a square is this lambda function. We denote the lambda function by the keyword lambda. So we write that lambda x is x into x, and we have to print square 5. So what happened here? Square is the name of the variable that is going to that is going to store the function inside it. So square is the function here. Lambda denotes that this is a lambda function. So we are going to define it in a single line. X is the argument that we need to pass here. And it says that we have to do x into x, that we have to return the square. And after calculating the square, we have to print this. This is what we are writing in the next line when we are calling it. So if I try to write it myself, this is how we can write it. So we have a variable that is the name of the function. Now I will use this lambda keyword to denote that this is a lambda function, a single line function. X is an argument here, and I am doing f into x. So what does it mean? It means that it will return x into x. Okay, now if I will print this yeah. So what is going to happen here? It says that this result is a function name. Yes. So we are calling the function by its name, and I am putting into an argument inside this function, and then I am printing it out. So now it is giving me the result, that is 25. So what is different from the normal function is that we are writing this function in a single line instead of so many lines as we used to do earlier. So here x is the argument, and x into x is the evaluated expression returned automatically. So this is how we are going to use lambda function. Okay. Now we have multiple argument lambda. So if I want to take many arguments here, then I can simply write them after the lambda keyword using a comma, and we will do the rest of the things ourselves. So if I want to write another lambda function here for adding two numbers, then I will write, I will first specify the name of the function, then I will write the lambda keyword, then I'll write the two parameters that I'm going to use, and then I will write the execution. And lastly, I am going to run these two values with the arguments 3 and 5. So now what will it return? It is returning 8. So this is how we will write a lambda function with multiple arguments. So when when are lambda function useful? So lambda function are quick and short-lived. Pass as higher order argument to function like map, filter, and sorted. So we will be learning this map, filter, and sorted. You don't have to worry about this right now. All you need to understand right now is what lambda function is and how we pass arguments in there. Yeah, so we have to understand. Yes. So we have to understand what lambda function is and how we are going to put singular or multiple argument inside it. So now there is a comparison. Yeah, so now there is this comparison between lambda and normal function. So in case of normal function, we define it using the def keyword, but in the case of lambda function, we use lambda keyword. The normal function span in the multiple lines and can be used for complex logic, but in case of lambda function, these are many very simple function that can only be written in single line expression. The normal function has explicit function name required, but lambda function can be anonymous. Maybe we can write it without any name. In the case of normal function, we require an explicit return statement, but in lambda function, we do not have to write a return statement here. It automatically returns the expression result. So these are the differences between lambda and the normal function. Okay, now we have to understand about the scope. In the last video, we learned about the local variable. I had explained it that local variable are those variables that we define inside the function and they do not exist outside the function. Their existence is only defined inside the function. We can use that variable inside that function only. If we try to access that variable outside the function, then it will result in an error. So that is how we were defining the local variable then. So they were declared inside a function, created when function start, destroyed upon a return, accessible only inside the function. So this were the local variable, and instead global variable were those variables that are declared outside all function and can be accessible throughout the entire program. So these are the variables that we define outside the function. So if I will give you an example, I have num equal to 5. Then I'm defining a function num return. Inside this function, I am making a variable that is num1 and I'm assigning it to a value 7. And then I print num1. And now I am going to run this function. I'm going to call the function up, and I am also going to print num from this part, and I am going to print num1. So now if I run it, what will happen here? For the first, when I am calling this function, it is declaring this variable num1, it is assigning it a value 7, and then it is printing this value, so we are getting 7 here. In the second case, we have print num, so this num variable is getting assigned here. This is a global variable, it is not defined inside any function, it is defined outside the functions, and so we can print it here. But now if I am trying to print this num1, we are getting an error here. We are getting that name num1 is not defined. Why? Because num1 is defined inside this function. Num1 exists only inside the function. It doesn't exist outside the function. So if I write this print statement inside the function, that it gets this num1 and it is printing the value. But if it will try to print it outside the function, then its existence is not there. Hence, we will get this error. So this variable right here is a global function, that is it is defined outside any function and it can be called anywhere inside the program. So this is a global variable, and this one here is the local variable. So this is what you need to understand here, the difference between global and the local variable. Okay. So as I told you before also, local variable is like this. We are defining a function demo and we are writing x is equal to 10, and then we have to print this x. Now when we call this demo function, it will assign a value 10 to this variable x, and then it will print the value. So this x only exists inside the demo function. It cannot be accessed or modified from outside the function, and the memory is reclaimed once the function finishes executing. That means when function is done, this memory is reclaimed. That means x doesn't exist after the function call ends. Then for global variable, we have x is equal to 100, and then we are defining this function where we have to print x, and then we run this function. So what happens here? We are declaring this value of x outside any function. So this is a global function. It can be accessed across all the function inside the module, can be accessed everywhere inside the program itself, and it persists for the lifetime of the program execution. So this is the global variable. So the next we have is how can we modify global variable. So if we have a global variable and I want to change its value inside a function, then I will use this global keyword. So why we use the global keyword? Why is the global keyword needed? So without global count, assigning a value inside update creates a new local variable with the same name instead of modifying the existing global variable. So what happens here? In this example, we have count is equal to 10. Then we are defining an update function where we have to change this count value by incrementing it. and then we call this update function, and then we print the count. So what is happening here is, when I'm using this global keyword here, it means that this count is a global variable, and we have to get to this count variable in the global scope, and then we have to update the value. But if I won't be using this global here, it will consider count to be an local variable, and it will make a new variable named count, and then it will increment its value. It won't be changing the value of count from here. So whenever we have to change the value of a global variable, then we use the global keyword. Okay. So now here is the summary of what we have learned so far. Local versus global variable. So for declaration, local is declared inside a function, while global is declared for all functions outside all function. As for the lifespan, the local variable's lifespan is temporary. So when the function call ends, then the lifespan of a local variable ends as well. But global variable exists throughout the program. Then we have scope. The local variable's scope or accessibility is only inside its function, while global function is accessible throughout the program. Then we have shadowing, that local variable can override global within the function if we use the global keyword. But in case of global variable, shadowed if local has the same name. So yeah, this is what we are. This is what we have learned so far. Okay. Now we have to learn about the recursive function. That what recursive function is. Okay, so what is a recursive function? The definition says that it is a function that calls itself directly or indirectly to solve a problem by breaking it down into smaller or self-similar sub-problems. Okay. So we will understand this using an example, but before we get to know that, let me explain you the definition itself. The recursive function is a type of function that calls itself directly or indirectly to solve a problem. So what happens in here is that when we call a function here, then inside that function, the function is calling itself again and again and again. So it starts a chain. Hence, it is called recursive. For example, I am saying that so here is an example of writing a factorial by the recursive approach. So how we are going to do it? We write a function factorial 5. Inside the factorial 5, we call another function, that is factorial 4. Then again, we are calling that similar function with the value 3 in here. Then again, we are calling the function factorial with 2 value, and again we are calling the function with 1 value, that is the base case, and hence we stop here. So what is happening here? We have called only this function, and this function is calling itself in another argument, and similarly it is repeating the same calling of itself till we reach the base case. So this is what happened in recursion. A function will call itself again and again unless it gets into the base case. And after we reach this point, then we go back. We will first finish this function properly. Then we will reach back to this, then this, then this. And finally, we will return back to our original function that we had called. So this is how recursion works. Now this is an example of factorial using recursion. How we can write factorial using recursion. So what happens here? We are defining a function factorial, and we are passing an parameter inside it, that is n. So we are first checking if n is equal to 1. If it is true, then we can return 1. If not, then we are keeping n, and we are again calling the same function with n minus 1. So what happens here? Unless n becomes 1 and this base case is met, until that this factorial function is going to call itself again and again with one decremented value. So if we call this print factorial, then first the factorial with the 5 as argument will run. It will check that 5 is not equal to 1. So it will again, it will keep this n value. That means it will keep 5. And then with multiplication value, it will call factorial 5 minus 1, that is factorial 4. Then it will have this 4, and it will again call factorial 4 minus 1, that is 3, then 2, and then 1. And now at last, when n will become 1, it will return 1. So yeah, so this is how one function can call itself again and again until a base case stops of infinite call loop. Okay, now we have to understand the pros and cons of recursion. So what are the advantages of recursion? These are that we get cleaner and more elegant code structure and the natural solution for trees, graphs, divide and conquer problems. So when we write any complex code structure, then recursion plays a very important role. It is very elegant and is cleaner and is easy to understand. The disadvantage is that it uses higher memory consumption. Why? Because it uses stack. Whenever we get get into another function side a function, then the value gets stored in a stacks one by one, and so it uses higher memory consumption. Then we have slower than simple loop for larger iteration. Yes, it makes the loop slower. Why? Because it is using stack and there are many large iterations inside it, and there is a risk for recursion error if base case is missing. If there is no base case, it will result in an infinite iteration, and this will call recursion error. So these are the pros and cons of recursion that we have to understand here. Okay, now we are getting into the last topic of this video, that is the mathematical function. Yeah. So the next topic that we have to understand here is the mathematical function. What we have here is that wait a minute. Mathematical functions here. So Python includes a built-in standard module named math that provides access to mathematical constants and mathematical operations. So you have to first understand what modules are. So modules are the pre-written block of code that can be used in our program, that can be imported inside our program, and you can use that code without writing it ourselves. So modules provide reusability, and one of those modules is the math module, which contains all the mathematical constant and operation. So we do not have to write the mathematical operation ourselves. We do not have to write the full expression, full equations of maths, and we can simply import the math module, and we can use it simply. We can use the predefined functions simply in our program from this math module. So the common math functions that is provided by the math module are this. The first one is this square root function that calculates the square root of x. So this is the way of doing it. If I write math dot sqrt16, then it will print the result 4.0. Then we have ceil function that provides us the nearest integer, rounds up to the nearest integer. So so if I write math dot ceil 4.2, it will return 5. Then I have floor function that returns rounds down to the nearest integer. So if I write math dot floor for 4.9, then it will give 4. Again, we have this factorial function. So instead of writing the whole function to find a factorial, we can simply call this factorial function, and it will return the factorial of x. So if I write math.factorial 5, then it will return 120. We do not have to write the whole code ourselves. We are just importing the codes from the module math. Then we have this power x and y. Yeah. So this is used whenever we have to return x raised to the power y. This can be used as an exponential operation. So when I write math dot power 2 3, then it means 2 raised to the power 3. So we will get 8 in the answer. In the last we have fabs that fabs. So we are getting here absolute float value. So see, there are two functions here. One is abs, only abs. That means it will give the absolute value. And then we have this fabs, that is fabs, that it will give absolute float value. So what it will do that it will return only the positive value from the number that it will be passed inside it. So this is how we can use the functions from math module. This will lessen our time. We do not have to write the code ourselves. We do not have to write the whole functions ourselves. We can just import them directly from the module itself. Yes. Now here is an example how we can use math module. So the first thing that we have to do is to import the math module. If we do not import the math module, then none of these will work. We have to import the math module, and then we can write math dot function. Whatever function we need to use, we can write them as math dot function name, and we have to pass the argument inside it, and it will work. For example, here we say print math dot square root of 25. So we return as 5. Then we print math dot seal 5.2. Then we get 6. If I write print math dot floor 5.9, we will get 5. So this is how math module works. Next is the trigonometric function. Yeah. So next is the trigonometric function. So the math modules also provide us with a trigonometric function, that is math dot sine, math dot cos, and math dot tan. So all trigonometric function expect angles in radians, not in degrees. So this value of x will be angles in radians, not in degree, that you have to learn. So if you are getting let us suppose you are getting input from user that is in degree, you need to first convert it into radians before passing it inside this function, that is sine, cos, and tan from the math module. And then you have to you can perform your trigonometric function. So for example, here we have to first import the math function, and then we are writing print math dot sine, and inside it we are printing math dot pi by 2. So yes, that means that we are trying to print sine 90 degree, that is 1. Similarly, here we are trying to print math dot cos 0, that is 1 again, and print math dot tan of math dot pi by 4. So pi by 4 is 45 degrees. So math dot tan 45 degree will be 0.999, that is approximately 1. So this is how you can use the trigonometric function from the math module. Now here are some of the practice questions that we should do. After studying all of this, we can easily solve this question. The first question says create a function with a default argument for country name. Oops, was country name, yes. So what we will do here is so we are defining a function that has a default argument for country name, right? So we have to write a function, let us say country name. This is the function name, and inside we have to provide the name of a country. So in our general case that we have learned so far, we will just write it like this. This is what we have been doing, right? But if I want to give a default value to this, if I want to give a default argument, then I will write it like this. So now, if I call this country name with, let us say, Nepal. So now, if I run it like this, it will print Nepal. But in case when I am not giving any argument inside it, if I'm going to leave it empty, then in that case, it will print the default country name, that is India. So this is how this code is going to work. Next is write a lambda function to multiply two numbers. So yeah, we have to write a lambda function. So first we need to write the name. Yes, this is the name of the function we have to write. And since it's a lambda function, we use lambda keyword here. Okay. And what do we have here? We have to multiply two numbers, i.e. we need to take two parameters here. Let us consider it A and B. Yeah. And what we have to do here is that we have to return A into B. Yeah, this is what we need to do. So now if I will run, if I call this function inside my print function with two values here, then it is going to run. It multiplies 3 and 5 and it provides 15. So this is how you can write the lambda function for multiplying two numbers. The next question says write a program to find the factorial of a number using recursion. So we have to write a program to find a factorial of a number using recursion. Okay. So we have considered this example earlier also. We have to write a factorial of a function, let suppose it to be num. Yeah, what we are going to do, so when we are writing this recursion, we have to first specify a base case, that is n is equal to 1. If n is equal to 1, we will return 1. Else, if there is the num is not equal to 1, then what we will do is we will return, we will keep this num with us and we will have this multiplication and we will call the factorial again inside it with num minus 1. Okay, so this is how we are going to write the factorial function using recursion. So now if I print this factorial of a number and if I say the number is 5, what will it show me? Yes, now it is showing 120. So it is working correctly. This is how you can write factorial function using recursion. Okay. Next we have find the square root of user input number using math square root. So I told you earlier also, if you want to use any function that belongs to the math module, you have to first import math module. So the first step that we need to do is import math. We need to import the module so that we can use the function inside it. And now we have to find the square root of a user input. So we are going to take a user input that is done using this. Yeah. So here we are getting to enter a number and we are storing it in the variable name num. And then we can print the square root. Yes, we have to find the square root of the number. Yeah, okay. So what we will do here, we will call math dot square root function and inside it we are going to keep this num. Now let us run it. So it is asking for the number. Let us give it a number 636. So what is it returning? It is returning 6. Why? Because the square root of 36 is 6. If I give it a bigger number, let us say I am giving it 144, then it will return 12. So yeah, this is how it is going to work. You have to first import math and then you can use it to use the function inside the math module. Display the sine value of 90 degree after converting degrees to radian. Okay, so for this example as well, you have to first import math because if we are going to use the math.sine function, then we have to get this math. Okay, now you have to understand that we have 90 in degrees, but we want it to be radian. Yes. Okay. So now we know that the value of pi is 180. Yes. So if I do pi by 2, that will make it 90. Yes. We can write it there like that. So I will write print math dot sign. And inside it, I'm going to write math dot pi and I'm going to divide it by 2. Yeah. So this is how it does. It returns the value to be 1 and we know that sine 90 degree is 1. So all we need to be careful about is that how we are going to convert this degree value into radian. This conversion is important to understand that how I am writing 90 degree as pi by 2. But this is also basics because we have learned this conversion very well in mathematics itself. So we can write the code easily. Okay. So throughout this session, what we have learned is that we learned about the default argument and we learned how we can provide default fallback values that can be used if there is no arguments being provided in the function call. Then we learned about the keyword argument that is used whenever we do not want to use the positional argument and we pass the argument using the names of we by using the names of the parameter. Then we learned about the lambda function where we used inline anonymous single line function. Then we learned about scope. We learned about local and global variable. Then we learned about recursion, how a function call itself in its execution. Then we learned about math module and how we get the built-in mathematical functions inside from this tool, from the module. So we can use it in our program instead of writing lines of code for doing the operations. So this is it. This is what we have learned in this video. In the next video, we are going to cover strings in Python. So we will learn string fundamental. We will learn the indexing in string. Then we will learn how we do slicing in string. We will learn all the string methods. And we will also do some string operations as well. So this is what we are going to do in the next lecture. So yeah, this is it for this video. We will learn string in Python in the next video. So till then, bye bye.